Welcome to the Hacksplaining video tutorial series. This video shows you how you could be revealing system information that will help attackers target your site. When an attacker targets your website, they will try to learn as much as possible about your stack so they can determine how it can be compromised. If your site unnecessarily exposes information about the technology it runs on, you're making life easier for them. An attacker has a wide variety of tools available to them when probing your site for vulnerabilities. Let's look at some of the ways you might be leaking information. The first thing an attacker will try to figure out is what web server you are running and the language it is written in. Many web servers describe this information in HTTP headers, which is great advertising for the web server vendor, but bad news for you. Listing the web server in the HTTP headers does nothing for your users, but will tell an attacker which exploits they can try. Make sure that you turn off this feature in your web server configuration, or even better, misreport the web server. URLs can also disclose information about the web server technology. Avoid paths ending with file extensions like PHP, JSP, or ASP, and design your site to use clean URLs. Cookies can reveal information about the server you are running. The name of the session ID parameter often gives a clue to the server-side technology. Use a generic parameter name if this property is configurable. Attackers sometimes deploy complex fingerprinting tools to determine server type. By submitting non-standard HTTP requests, like delete requests and broken HTTP headers, they can heuristically determine the likely server type by examining how it responds in these ambiguous situations. Some web servers have plugins that will attempt to obscure this telltale behavior. However, the simpler measures that were already mentioned are generally enough to protect against automated attacks. Another location where your site is prone to leak sensitive information is error messages. Make sure error messages are sanitized so they don't reveal details about the data store, the paths of template files, or stack traces. It's important to have a generic HTTP 500 error page and keep detailed reporting in server-side logs or reporting systems. This applies to AJAX responses too. Failed asynchronous HTTP responses will not generally be rendered in the browser, but if they return detailed debug information in JSON or XML, a hacker somewhere thanks you. Rich client applications often pass significant amounts of raw data to the browser. Be careful how much data is exposed in JSON packets, for example. Modern frameworks make it easy to serialize data objects as JSON or XML, but you should take care that information is sanitized before being passed back to the client side. Client-side JavaScript may contain vulnerabilities. If you use common libraries, an attacker can look up your version in an exploit database to see if there is anything they can take advantage of. Be sure to obfuscate your JavaScript code, including third-party libraries. Many libraries require you to keep the copyright notice in the deployed code, but if possible, it's not a bad idea to hide version numbers in the code and avoid revealing versions in file names. Be sure to sanitize any source code or template file that generates HTML too. It's easy to accidentally leave sensitive data like server names and addresses in code comments when rushing out a release. Using static analysis tools and performing code reviews will limit the likelihood of this happening. Ensure you strictly separate public and configuration directories, and make sure everyone on your team knows the difference. Revealing configuration data over HTTP is a gift to a hacker. If you accept file uploads from your users, remember to scrub any potentially sensitive data as a courtesy. Be careful not to leak location or personal details in EXIF tags. Lastly, be aware that tools like Nmap can often be used to determine the operating system you are running on. Nmap uses TCP/IP fingerprinting, sending ambiguous data packets and looking for distinctive responses.